us see the implementation of k-neighbors algorithm. And let me make it very, very simple for you. So what we can do is we can have it in three steps. The first step I can basically suggest is the step one as data preparation. And then we will have second step as model creation, model implementation. So that is second step. And the third step would be model evaluation. So in these three steps, we would try to work and we'll try to get our algorithm implemented. So for data preparation, we need certain libraries. Let's say I import pandas as PD and import numpy numpy as np. We may also require later on import matplotlib.py plot as plt. So these libraries probably will require here. And I need to have the dataset downloaded. So UCI machine learning is a better option to get any dataset downloaded. So we can go to this particular website, UCI machine learning repository, and you can click on view all datasets and you can search for the iris dataset and you can download that. So iris dataset was visible here only. So I'm clicking on this iris dataset. We can download it from here. So iris.data and we have iris.names. So iris.data will be the data where actual data is present, and names will be that file which will be actually representing the description of the data. So let me upload the two files. So these two files I have uploaded, and here you can see they are loaded as well. If I simply double click on names, it tells me everything about data, that this data is iris plants database and the kind of columns we have, relevant information. This is perhaps the best known database to be found in the pattern recognition literature. Okay, so it has got sepal length, petal width, sepal length, sepal width, petal length, petal width, and the class. So let us work on this particular data set. Let me copy the path from iris.data and we will load this particular data here. So data is equal to pd.read underscore csv, and in brackets we will put okay, and here we will try to show data.head and how the data is loaded. The first first row has been considered as column, so we will just write header is equal to none, and then we will get the data. Let us also initialize the columns, so we can just have data.columns columns is equal to, and we know that first one is sepal length, second one is sepal width, third one is petal length, and fourth one is petal width. And we have fifth one as well, which is class label. So I'll name it as label. So this is what is our final data which we have. Now another thing I will do is from sklearn.model selection, we will import train test split. Import train test split. Now this train test split is going to help me to split this particular data into training and testing. So train underscore test underscore split split. Now we will use this function train test split. How do we do that? X underscore train comma X underscore test, Y underscore train comma Y underscore test is equal to train test split, and in bracket we need to pass the whole of the data. So here we have data, and if you see that data of which columns. So we can have, or I can just have data dot probably this way. Okay, drop or dot lock, and I will be selecting all the rows, and the columns would be from starting 0, 1, 2, 3. So from starting till 0, 1, 2 till 2. Okay. So this much data we will get. Just to get a confirmation, what we will do is we'll just try to get that what exactly this is going to fetch. So here we wanted all the records. So data.log. Okay. And we want, this is bringing all the rows, and here if I mention SL, then in that case it is going to bring only SL. So I want SL and SW, I want PL and PW. So these things are something which I want. So this I will be putting inside this function. This is my X actually. Or simply I can have X and Y over here, and I can store this much into X. So let me store this much into X. So X is equal to this much, and Y is equal to, we will have same thing, data dot log and colon, and here we will have only the label. Okay, only the label we will have. So X train comma X test, Y train comma Y test, and what we will do here, test underscore size is equal to, we have two mechanisms, like either I can give like 0.2, so 20%, or I can write, let's say 15, only 15 rows I want as test data. So both the ways are there. If you want, you can give number, and number of records basically will come as test size. So I will be making it as 20%, and then I'll be making random underscore state is equal to 1. So I'm giving random state as 1. So we have the data split into training and testing. So we have TRAI and ING training data. So training data is X underscore train and Y underscore train. This is training input and output. And similar way, we have test input and output. So let me just show you the shape. So shape of the X train and shape of the Y train is like this. So here you can see that it has got 120. So 30 records, which are 20%, they are into testing. So first part is done. We have prepared our data. Now second part is model creation and implementation. So for that purpose, we will have from sklearn dot, we will have neighbors here because this algorithm comes under neighbors. So from sklearn.neighbors, import k nearest neighbor, basically k neighbors classifier. So this is a classification problem. So k neighbors classifier, and k and c, k neighbors classifier is equal to k neighbors classifier. We'll have to give the name of that particular object, and here inside the bracket I can mention the number of neighbors to look for. By default it is 5. By default the metric which is used is Euclidean, so I'll keep them as it is. I'm making no changes over here. Now what I will do is knc dot fit. So in knc dot fit I'll be passing X underscore train, and I'll be passing Y underscore train. So X train and Y train I'll be passing. This is the training. Here the model is getting trained. Now I can get the prediction. So prediction I'll store in ypred. So ypred is equal to knc dot predict, and here I will put X underscore test comma Y. So I just need to pass X. So now this Y underscore pred is having the predicted values, and we need to actually match these predicted values now. Okay. Match these with what? Match these with the y test. So y pred is the algorithm's prediction, and y test is the prediction which is given by which is by default, okay, in the data. So the differences between them I need to check. So that I can check with the help of model evaluation. In case of model evaluation, we write from sklearn dot metrics, and here I can import ACCURACY accuracy score, and along with that PRECISIN precision score. So accuracy score and precision score, only two I am importing as of now, and accuracy is equal to accuracy score, and in bracket I need to write the y underscore test and y underscore pred. This is going to give us the accuracy. So print a, and that is the accuracy now. So here you can see the accuracy is 1. Okay, all the correct predictions. Similarly, precision we will try to see. So P is equal to PRECI precision score, and here I'll put y underscore test comma y underscore pred. So let me print P, and let us check what is the. So it says target is multi-class. So when target is multi-class, then in that particular case we have to do a change in the average setting. So let me make that particular change comma average, average, and I'll make it micro. So average is equal to, and here I'll change the method as micro, and then let us basically print the value for P and get the final output. So precision is also 1, that is 100%. So that was the implementation of k neighbors classifier. Let us wait for some time and see and explore certain more algorithms. Thank you very much.